Welcome to today's video, where we'll explore how to use the contains function on an unordered set with a custom class. This topic is crucial for any developer working with CAI and wanting to improve their skills in using data structures efficiently. In this video, we will delve into the specifics of how to utilize the contains function with a custom class in an unordered set, covering what it entails, its benefits, and providing examples to solidify your understanding. If you're new to CO or are looking for ways to enhance your programming skills by learning about data structures and algorithms, this video is perfect for you. By the end of this video, you'll have a clear grasp of how to apply the contains function with custom classes in unordered sets, making your code more efficient and readable. When working with CAI, especially with large data sets, it's essential to understand how to effectively use data structures such as unordered set. An unordered set is a container that stores unique elements in no particular order, allowing for fast lookup, insertion, and removal of elements. However, when you're dealing with custom classes, things can get a bit more complicated. The contains function, or more specifically, the find function in CIT, allows you to check if an element is present in the set. But how do you use this function when your set contains objects of a custom class? The key lies in understanding how to properly define a hash function and an equality operator for your custom class. Let's consider an example where we have a simple person class with a name and age, and we want to store unique person objects in an unordered set. To do this, you need to tell the compiler how to determine if two person objects are equal for the equality operator, and how to generate a hash code for each person object. For instance, you might decide that two person objects are considered equal if both their names and ages match exactly. Similarly, for hashing, you could create a hash value based on the name and age of the person, ensuring that different persons with different names or ages will likely have different hash values. Here's how you would go about defining these in your code. You see, it's not as complicated as it sounds. By telling CETU how to handle equality and hashing for your custom class, you can easily use the find function or check containment with an unordered set containing objects of that class. To use contains, or more accurately, find, on an unordered set with a custom class in CAI, you need to define how equality and hashing work for your class. You can achieve this by overloading the equality operator and providing a custom hash function that can be used by the unordered set. This process ensures that the unordered set can efficiently store, find, and remove elements based on your custom criteria. In using the contains function with an unordered set containing objects of a custom class in CE, is straightforward. Once you understand how to define equality and hashing for your class, it's a powerful technique that allows you to leverage the efficiency of unordered sets even with complex data types. If you have any questions or need further clarification on this topic, please don't hesitate to ask in the comments below. Your engagement helps us tailor our content better to your needs. If you found this video helpful, consider liking it and subscribing for more tutorials and explanations on programming topics. Thanks for watching.